Hello everyone. In this video, we are going to see all about narrow and wide transformation in Apache Spark. Before we get into the details, let's understand some key terminologies. First, let's understand what is a RDD. RDD stands for Resilient Distributed Dataset. RDD is the fundamental data structure in Apache Spark. It represents an immutable distributed collection of objects that can be processed in parallel across a cluster. In this diagram, we have two RDDs. This is RDD1 and this is RDD2. Each RDD has three partitions that are processed in parallel in this cluster. An RDD is immutable. It means that once the RDD is created, it cannot be changed. Any transformation creates a new RDD instead of modifying the original. In this diagram, the arrow represents a transformation and it is creating a new RDD. RDD transformations are lazily evaluated. That means that Spark does not execute them immediately but builds a lineage or an execution plan and runs it when an action is called. RDD is fault tolerant. If a partition is lost due to node failure, Spark can recompute the RDD using original data and transformation logic. This recovery mechanism makes RDD highly reliable in distributed environments. Now let's see what is a transformation in Apache Spark. Transformations are the foundation of distributed data processing. A transformation is an operation that creates new RDD from an existing one. These transformations define a logical execution plan and enables parallel processing across a cluster. Transformations in Spark fall into two main categories: narrow transformation and wide transformation. Now let's see what is a narrow transformation in Apache Spark. A narrow transformation is one where each output partition depends only on a single input partition. All data needed to compute the output stays within the same partition, so there is no data movement across the cluster. Because of this, there is no shuffling between the nodes. Narrow transformations are faster and more efficient, reducing network overheads. Now let's see what is wide transformation. In wide transformation, each output partition depends on multiple input partitions. Wide transformation triggers a shuffle, resulting in redistributing the data across the cluster. Wide transformation causes inter-partition dependencies, requiring coordination between partitions. Wide transformation leads to increased network I/O and computation overhead. Wide transformations are generally slower and more resource intensive due to data movement. Now let's see the practical implementation of narrow and wide transformation. Here is my Spark session which is up and running. I have created an RDD and a data frame. We have set of names and their corresponding score. Let's print this RDD and the data frame. RDD dot collect df dot show. Let's run it. Here is my data. Let me add a print command. Here is the data for my RDD and the data frame. The first transformation that we are going to see is map transformation, which is a narrow transformation. For the RDD, we are printing the name and their corresponding score multiplied by 2. We are using a lambda function for each element of the RDD. There won't be any data shuffle between partition, so map transformation is an example for narrow transformation. The next transformation is filter transformation. For the RDD, we are filtering the records which has the score greater than 15. This filter transformation keeps the element of the RDD that satisfies this condition. Filter transformation is an example for narrow transformation. The next transformation is flat map. Flat map is also similar to map transformation, but it flattens the result. We have a list with two words, hello world and good morning, and we are creating an RDD using this data, and we are using flat map transformation to split this data based on space. Flat map is also an example for narrow transformation. The next transformation is with column transformation. We are creating a new column double score with a score multiplied by 2. Here is the new column that got created. With column transformation is an example for narrow transformation. The next transformation is select. We are selecting the name column. Here is the result. Select is an example for narrow transformation. The next transformation is squelch. Using the squelch function, we are merging the partition to 1. Squelch function avoids data shuffling. Squelch transformation is an example for narrow transformation. We are printing the number of partitions. Here is the result. The next transformation is union transformation. We are creating another RDD and a data frame with additional data, and we are doing an union with the previous data frame. Here is the new data frame data. Union is an example for white transformation. Similarly, we are doing an union with the RDD. Our new RDD is RDD2. We are doing an union with the existing RDD and we are printing this result. Here is the RDD result, which is an union of both the RDDs. Union is an example for white transformation. The next transformation is distinct. Distinct is an example for white transformation. We are removing the duplicates from the RDD and from the data frame. These are some of the examples for narrow and wide transformation. I hope you got a fair idea of narrow and wide transformation in PySpark, and I am sure that you learned something new today. If you do like this video, please consider to subscribe, and I will see you in another interesting video. Thank you.